Hey everybody, it's Mr. N here, and this is the next lesson. This one is on rotations. So geometric rotations. All right, a rotation can be referred to as a revolution as well. So we can call it a revolution, we can call it a rotation. Either one works. Now, here in a rotation, we're going to be moving in a circular direction. So let's recall something that I've always told you. And if you have an axis, the positive direction is always counterclockwise. Let's just put that in another color here. So the positive direction is always counterclockwise. We're going to write a rotation by using a script letter R. So I will use it like that. If you see it typed, it may look like this, but it'll be a script letter. Now, when I put in a rotation, I always need to specify where I'm rotating. If I'm rotating about the origin, I will put an O right there. And then I will put my angle of rotation. So this one would be a 40-degree rotation. So if I'm rotating about the origin, that means I'm rotating about right there. And if I have a point, I'm going to move that 40 degrees. Well, how do we do that? So let me draw another axis here real quick and just show you. So if I have a point, say my point is out here, okay, and I'm going to rotate 40 degrees about the origin. So I would connect this, and then I'm going to go 40 degrees, and that would be my new point right there. So that would be 40 degrees. If this is P, that would be P prime. So that's how I rotate something. Now, I don't have to rotate about the origin. I can rotate about any other coordinate. So that's something that we need to be aware of. Okay, a rotation about point O through x degrees is a transformation such that if a point P is different from O, then OP prime equals OP, and the measure of angle POP prime equals x. If point P is the point O, then P prime equals P. And what this is saying is, look, if my point is on my actual, so like if right here I'm rotating about the origin and my point is on the origin, wherever my point is, if it's on the point of rotation, it's not going to move. So like if I have a point out here, this point will move, but this point ends up staying. So A, and if I put B here, I'll still end up with A prime and then B prime right there after I do that rotation. But remember, A, since it's rotating about itself, doesn't move. All right, a rotation is an isometry, so we're not changing the size, we're not changing the shape, so we know that a rotation will be an isometry right here. Okay, and then we can also say that it's a rigid motion. So often we're going to use this letter H, so we'll talk about this, to mean a half turn. So H will just be a rotation about a point, we'll say the origin, by 180 degrees. So instead of writing all this out, we'll just use H. So H about O means a rotation about point O, 180 degrees. So one thing to note for a rotation that's interesting is if you have the coordinate xy, let's use a different color here. If you have the coordinate xy and you do a half turn, the coordinate maps to negative x, negative y. So right here, here's a couple more that we can, well, one more that we could talk about. Here is a half turn. We have xy maps to negative x, negative y. And if you do a 90-degree rotation, xy maps to negative y, x. So they flip and the y becomes the opposite. So if you do 180, you get negative x, negative y. And if you do 90, then you'll get negative y, x as your new coordinate. If the angle of rotation in the coordinate plane is not a multiple of 90, then we need to use sine and cosine ratios to find those image. And we don't know sine and cosine yet. We will learn that later in this course. But for right now, we're only going to focus on half turns and 90 degrees. Anything else we will do graphically. All right, let's take a look at what we got over here on this page. There is actually one more I do want to talk about, and that's 270 right here. So for 270, just like 90 we switched them and put a negative on the y. For 270, we're going to switch them and put a negative on the x. In this book, they use a and b, but we could say, well, let's just go ahead and recap this, and we'll say, and we'll use the origin here. A rotation about the origin, and we'll start with 90 degrees, such that x comma y will map to negative y comma x. That's for 90 degrees. And then we'll do the half turn version. We'll just say a half turn origin, maps x, y to, and this will be negative x, negative y. And again, we can call this one a rotation about point O, 180 degrees. That means the same thing. And then we'll recap with the last one, a rotation. This time let's do 270 degrees. So if I do 270 degrees, oops, I wrote this, forgot to put the origin there. So let's put about the origin 270 degrees. Your xy point will map to, now this time we're going to flip them again, so we'll have y and x, but it's the x that becomes negative. So these are the three that I want you to remember. It would help to memorize them, and these are the three we'll use often. If it's anything other than that, we probably will do it with a graphical method, and I'll show you how to do that later. So let's take a look at what we got here. As we said before, I'm not sure why that's not moving with everything. That's kind of odd. Let's see if we can move that separately. There we go. A rotation is a transformation in which a figure is turned about a fixed point. Then we have the center. So again, if this is my fixed point down here, and I'm rotating this object like this, here's my distance from it. I keep that, so I preserve that distance, but I move it that 40 degrees, and all this moves with it 40 degrees this way, and that's for this example. If Q is not the center of rotation, then Q, this is what I said on the other page, this is how Q ends up at Q prime. But look at P. Since P is the center of rotation, it ends up in the same spot. It doesn't move. Now, a couple more things. Identifying rotational symmetry. So in a figure in a plane has rotational symmetry when the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. This point is the center of symmetry. Note that the rotation can either be clockwise or counterclockwise. Here's some examples. Right here, this is, if I call this at 0 and I move it 45 degrees this way, I end up like this. But if I move it 90, it ends up being the same as the original, so it has rotational symmetry of 90 degrees, or you can even say 180 degrees. So this has rotational symmetry of 90 or 180 because when you rotate it, it looks like the original. So the figure above also has a point of symmetry, which is 180 degrees rotational symmetry. So that's our point of symmetry right there like that. All right, so let's do a few examples here. And let's take a look at what we got. State another name for each rotation. A rotation about point O, 50 degrees. So basically what we're asked to do here is to just rewrite this. So 50 degrees, now think about it. You can, let me draw a little axes here for you. All right, if I go 50 degrees, right there, I can go all the way around and end up in the same spot. I can go the other way around and end up in the same spot. So what we want to do to these when they're asking us to rename them or state another name is you want to add 360 or subtract 360. So another name for this one would be a rotation about the origin. Now, if I add 360, it would be 410. Or I could say a rotation about the origin. If I subtract 360, this would be negative 310. So either way would work, okay? Either way would work. On this one, a rotation about point A, negative 90, we would still say a rotation about point A. And now, again, I'm going to go 360, and I could take the 90 and add 360 to it, right? And that would give me 450. Or I could take the 90 and subtract 360 from it, and that would give me negative 270. So either one of these answers, negative 270, would suffice. Okay, number 3. Okay, so this I know got kind of messed up. This should say A, B. This point right here should be C. We'll make this like that. This will be point D, and then that's point E. And this is my origin right here, is what I'm saying. So on this example, O is the center of the regular pentagon. Now this is key that it's regular. A, B, C, D, E. State the images of A, B, C under each rotation. Rotation of 144. Well, we need to determine, since this is a regular pentagon, if I go like this, all these angles in here will be exactly the same. Well, what will they be? Well, there are 5 angles in here, 1, 2, 3, 4, 5, and all the way around is 360. So if I take 360 divided by 5, I will get 72. So each angle in here, and let me erase some of this stuff so I can write it in a little bit better. I'm going to erase that. Okay, each angle in here is 72 degrees. So all these angles are 72 degrees. So now if I want a rotation about point O, where A ends up, okay, they want, state the images of A, B, C, D. A, I'm just going to do A. I'm not going to do them all because then it's too many to list. Well, we can. A would end up, if I'm going to go 144 degrees, I would go here to here. A would map to C. B would map to, well, there's 72, there's 144, would map to D. C would map to 1, 2, E. D would map to 1, 2, back to A. And E, A, B, C, D, E, that's the last one, would map back to B. All right, let's do the next one. I'm going to erase a lot of this because it's kind of in the way. So let's, if it lets me, it's not letting me now. Okay, interesting. Okay, we'll just do a different color. We'll go the other way. Let me try one more time erasing this. There it goes. But it's like really tiny. Let's get it bigger. There we go. Oh, it only does certain parts of it. That's so, okay, this software is wonderful when it works, but like it's kind of confusing when it doesn't. And one more try, it won't do it. Okay, so let's just continue on with another color. So over here, we're going to say negative 72, so I'm going to go the other direction. So A would map to, that's negative 72E. Okay, B, we're going backwards 72, that would be A. C, we're going backwards 72, that would be B. D, again, we're going backwards 72, that would map to C. And E right here, would going backwards, would map to D. So that's what they're asking us to do in this problem. All right, we're going to do more in class when we meet. We'll do those student journal ones. So hopefully this helped. Hopefully rotations aren't too difficult for you. Thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.